Imagine moving at 300,000 kilometers per second. At that speed, you could circle Earth more than 7 times in a single second. Missiles look frozen. Planets feel close. This speed has a special name, the speed of light. It's the ultimate speed limit of the universe. Nothing with mass can go faster. No engine can break it. No shortcut has ever escaped it. For centuries, we believed that if we could just go fast enough, the universe would eventually open up to us. But here's the uncomfortable truth. Even light is too slow. When fast becomes meaningless. Light doesn't need fuel. It doesn't slow down. It moves freely through the vacuum of space. And yet, when we compare its speed to the size of the universe, something shocking happens. Light stops feeling fast. It starts feeling small. That realization changes everything. Because if light itself struggles, then travel is no longer a technological challenge. It becomes a cosmic impossibility. The nearest star is already a problem. Let's start small. The closest star beyond our Sun is Proxima Centauri, about 4.24 light-years away. That sounds close, but even at light speed, a trip there would take more than 4 years. No stops, no delays, no slowing down. 4 uninterrupted years of travel just to reach the nearest star. For comparison, the Moon took 3 days. Mars takes months. And Proxima Centauri demands years at the maximum possible speed allowed by reality. That's not the edge of the universe. That's barely leaving the neighborhood. Our own solar system is already too big. Even inside our solar system, distances are deceptive. Sunlight takes more than 8 minutes to reach Earth. That means everything you see in the sky is already in the past. Mars can be over 20 light minutes away. Pluto is more than 5 light hours distant. So even our cosmic backyard is delayed, stretched, and vast. And this is still the smallest scale we'll talk about. The Milky Way, where travel breaks down. Now zoom out. The Milky Way is about 100,000 light-years across. If you fired a beam of light from one side to the other, it would arrive tens of thousands of years later. That means even at light speed, crossing our own galaxy is not a journey. It's a civilization-ending commitment. And the Milky Way is only one galaxy among many. Andromeda. Close, but forever out of reach. Our nearest large galactic neighbor is Andromeda, about 2.5 million light-years away. At light speed, that's 2.5 million years of travel, enough time for entire species to rise and go extinct. Even if humans survived that long, the Earth they left behind would be unrecognizable. And Andromeda is still nearby in cosmic terms. Galaxies come in groups, and groups become monsters. Andromeda and the Milky Way are part of the Local Group, a collection of roughly 80 galaxies. That group is embedded in an even larger structure called a supercluster, stretching hundreds of millions of light-years across. If you started traveling at light speed when dinosaurs first appeared, you wouldn't even cross half of it by today. And even this isn't the full universe. The observable universe, not the whole thing. The observable universe has a diameter of about 93 billion light-years. That number alone is mind-breaking. But here's the twist. This is not because light has traveled that far. It's because space itself expanded while the light was traveling. The universe grew faster than the light moving through it, which leads to a terrifying conclusion. The universe is expanding faster than light can chase. Some regions of the universe are moving away from us faster than light, not because they're breaking physics, but because space itself is expanding. This means there are places we will never see, never visit, never even detect. No amount of technology will change that. Those regions are gone, not destroyed, but permanently unreachable. The universe has an edge, but it's an edge we can never touch. Why even near light speed doesn't save us. Let's imagine the impossible, a spacecraft traveling at near light speed. Time dilation kicks in. For the crew, the journey feels shorter. For the universe outside, centuries or millennia pass. Return becomes meaningless. Home becomes history. And the energy cost? Absurd. To accelerate just 1 kilogram of mass to a fraction of light speed requires energy on the scale of entire nations, sometimes entire stars. And the faster you go, the worse it gets. Exponentially worse. Space becomes a weapon at high speed. At near light speed, space itself turns hostile. Dust becomes shrapnel. Atoms hit like nuclear blasts. Radiation becomes unavoidable. A grain of sand can release explosive energy. Space looks empty, but it's a minefield at extreme velocity. The psychological wall nobody talks about. Even if physics allowed it, humans would struggle. Years or decades in isolation. No rescue, no real return, no shared timeline with Earth. Interstellar travel isn't just engineering. It's a psychological experiment humanity has never passed. What about warp drives and wormholes? Science fiction offers shortcuts. Warp drives bend space. Wormholes connect distant points. On paper, they're fascinating. In reality, they demand exotic matter, negative energy, and unstable physics we've never observed. Even if they exist, keeping them open might require more energy than entire galaxies can provide. For now, they remain equations, not engines. The universe's quiet message. The universe seems built with a firewall. You can look, you can measure, you can understand, but you cannot cross everything. Not because we lack ambition, but because scale itself resists us. The irony that changes everything. The speed of light feels unimaginably fast, until the universe laughs at it. What once symbolized ultimate freedom becomes a boundary. And that boundary defines our place. The ending that makes it click. Here's the truth. We may never reach the edge of the universe, but we don't need to, because understanding it already changed us. Every galaxy we see, every ancient photon we catch, every equation we solve, is proof that curiosity travels farther than any ship. If humanity could break only one cosmic limit, which should it be? A. The speed of light. B. The expansion of the universe. Comment A or B and explain why. And if you want to explore what humanity might become beyond Earth, beyond tomorrow, beyond 2200, subscribe.